this off.
Yeah, and then I want you and David, I'm going to explain to you, we produce many thousands of this just for training the teachers of young kids.
Yeah, so how much does one of these cost?
Oh, they cost about $50.
Okay, so.
It's unfortunately, I could not make it to be,
Yeah.
Like.
Still, that's not bad.
No, but the University of São Paulo decided to put the collections available for the people that's been training to be teachers.
Yeah.
In science. We even did mathematics for probability, intuition.
Yeah. So tell me what's in the optics one.
Oh, the optics one, what we do is, this is the color. The optics one, you do all the deduction of the main ray optics. And then I explain how we can make a lens if we know the angular deviation of prisms and everything. So they build up the concept.
Right.
And then we can actually deduce the lens equation.
Yeah.
And then we simulate many things, all kinds of lens. This is by projection. And then they measure angles, all kinds. And then they construct on the board equivalent a microscope, equivalent a telescope.
Yeah. So we got lenses and prisms in here.
Yeah, lens, prisms. I used to put this in a box, a paper box. But then
I see. You got cylindrical lenses, so they can do it
project.
in a plane.
Yeah.
Yeah, that's nice. What do you use for a light source?
LEDs, and we have a Fresnel lens that produce the parallel beams, and then all kinds of, what we do here is project. So you just put a white paper on the table, and we project, and people can see all the like this is how it looks like.
Yeah.
It's a piece of paper on the table, and you project all the beams.
Yeah, yeah.
And then they deduce all the idea is you deduce the Fresnel law, and because if you teach the students about the reflection, and then you teach the spherical mirror, they think that doesn't obey anymore, but obey for each point. So they are able to reconstruct.
Yeah.
If they want to have a deviation for all the beams, obeying the reflection law, you have to have a spherical one, so everything comes to one point, and that kind of thing.
So this is all ray optics here.
This is all ray optics. This is all color and sensation.
Yeah.
So we do all kinds of, and now there is one that's not red, which is for, it's very beautiful.
Oh yeah, I like that.
Because the university wants something that was more permanent. This one, we create structure to show, this is all magnet. So by using the balls, you start to stick together, and you create the Bravais structures. This is more an interface of chemistry.
Or engineering.
Yeah, but this is to show.
So is this the box you were talking about yesterday, Vanderlei?
Yeah.
That's simple, yeah.
So we are about, you created three-dimensional structures, Bill, with this. So this is and then we explain minerals and the more hardness of the materials, how that is, why diamond is the hardest, and then.
So why is diamond the hardest?
See, there are two things. One is ability to remove, and that is if you can make a scratch in a material. This is one kind. The other one is deformation, which is the propagation of dislocation.
Yeah.
And turns out that diamond has a structure that you cannot propagate dislocation. If you start to propagate, it breaks. It does not afford the deformation. So it is a very hard material on the scale. And there are many other minerals, and we have a little piece of calcite. And calcite is very soft,
Actually, I didn't know the calcite was very soft, but,
Yeah.
but I know that it's
talco, gepsita, calcite is the fourth one on the hardness
yeah,
scale.
talc is the softest,
Is
right?
the softest.
No, so, but the nice thing about calcite is that it's birefringent.
Yeah, I know, but the idea here is to show in nature different things about this.
So is this the box you were telling us about yesterday?
No, this is the box I produce here.
I see.
And then I'll show you the box that was in the United States for nothing. And they now cancel. I said, what the? You know, the president another
I'd be interested in taking, information about this back to the, yeah.
And then we have the biology.
Oh, so
we
this
have
is very
chemistry.
nice.
We have
So this looks like a nice
Yeah.
microscope.
Yeah, this is, we don't produce this. I would like to put the microscope we did, but we turn out buying from China.
The thing that you were talking about yesterday, or
Yeah,
something
yeah.
similar? Yeah.
I used to, but I cannot match the cost, And that one you're gonna like. That's the thermodynamic, and the kid has to rediscover the ideal gas law.
Ah,
So I'm gonna show it to you.
O professor Banhato explica para os Prêmio Nobel os kits educativos criados pela sua equipe.
To teach kids to make interface and, otherwise they think that everything is applicative for cellular phone.
I'd benefit from this one.
Yeah, I can give you one. So this is
oh, this is nice.
I have to open and put, I thought the girl will put it, you're gonna like. Because it's quantitative, and then we apply in school. I made already 2,000 of those kits, and now they're going to different places.
Now, is this kit made here?
Yeah,
In
all
Brazil?
made here. No, it's made here in the university. We don't have a company
Okay.
yet.
I see.
So the two girls, there is a Cuban girl there, and the other one, and I make them work to produce. And then, of course, what we did is we develop all the you see, here is the temperature, and this is like a piston.
Yeah.
And then if you take the speed and you take the pressure, you can put different weights in here that comes in this. You stick on here, you actually get that it's linear, and then you vary the number, and it's also linear. So people can say that pressure is proportional to number, temperature.
Okay,
And the volume is the variable you measure. So.
but how do you get temperature?
By the speed of the motor. So we calibrate in three different speeds.
Okay.
It's the equivalent temperature, right? It's not the real
Yeah.
one. But they understand when they play with this that temperature is related to the degree of freedom. And then I did one, but it's not here, that we put two different balls, a big and a small. But that one I made in a big, and then you can find the concept of partial pressure. So this is this. And this is the most interesting, and I took to United States, is the colors. And then
Okay, but now one of the problems, I'm thinking with the two different sized balls, the velocity is going to be the same for the same setting of the motor,
Yeah.
but of course the temperature is not.
well,
Because
yeah,
the mass is
I know,
different.
but unbelievably, you get that the additions, you make one, make other, and the final pressure is close to the addition, which is the number. And this is to add and subtract color, as you know. I mean, you know about primary and
Sure,
secondary.
so how do you do the addition part of the thing? I can
Oh,
see
the
the subtraction.
addition part is done. Você não botou pilha em nenhum? So, the addition is by projection.
Yeah.
You see? We do the projection. Those are physicists. And then you can create.
Okay, that's good.
But I can show you that we make the kid to discover what components are in each color by removing the combination.
Yeah.
And
See,
you
I
may
used to do this with overhead projectors, but you can't find overhead projectors anymore.
yeah. And then we do this one you know, right? It's nice to explain the kids how it works,
The 3D.
the 3D, the stereographic imaging, and if medium put together, I'm gonna let you combine. We need a white paper, right?
Nesse momento, o professor Vanderlei Banhatti explica para os convidados prêmios Nobel que aqui estão no Instituto de Física de São Carlos os kits educativos desenvolvidos. E os professores que estou ao lado de Bill Phillips, Dr. David, a qual estão aqui entendendo todo esse processo educativo e de difusão científica que o professor explica.
I want from you a few words saying, well, we have to motivate the young people because I would like to put this in the bookstores, make a simplified version. Even here, like, you know, I told you, quanto que é o custo do mais caro?
O mais caro são 700.
Quanto?
700.
Yeah, even though it's about $50 the most expensive, but $50 today is nothing. I mean,
So what do you call your kits? What's the
we
name?
call Adventure in Science.
Okay.
But I'm a fan of the American program that was done by, I think, Clinton or something, that was give a microscope, give a binocular and a telescope to any kid in school. And I think that made a big difference.
Yeah.
And this is what we want to do, but our kits are a little more expensive.
Well, do you remember years ago, they had an optics kit that the OSA, what we now call Optica, made an optics kit, and I think it only cost $10, but that was a long time ago. And it had a few lenses, and some polarizers, and a diffraction grating. You remember that?
Yeah. Well, I brought it for the girls, but I think you see,
then
before understanding polarization, diffraction, it's nice to understand. You know, like
Oh,
how the
absolutely.
rays. What is
Sure.
if you ask what is a beam and what's a ray, the students in high school they say no, it's the same stuff. They don't know that a ray is no dimension, is a line, and you can do all the geometric optics. So anyway, we produce thousands. We put in many schools. We got the report, and now we made the final version. I have one on electricity, but there is no. It's to discover why there is electrical resistance. So it's a board with nails, and you can shake, and then you drop a little balls, and you see potential. And it is again quantitative. You can deduce the the two laws. One that depends on the resistance will depend on the length and the area, and the other one that is proportional to the potential, which here is the gravitational potential. And but that one we could not fit. It needs a board that's we
This is nice, Vanderlei. I'm sure this could be used to good advantage in the U.S. Yeah, this is great.
I'm taking each trip. I'm taking a collection, and I have two students from high school in College Station that took the optics, and they did it for their students, and then their teacher called me to go there. I'm going in January,
Yeah.
and we're gonna make a little club. Like here, I start 110, 104 science clubs in the schools, and that make a big difference. You know. We are getting students on those clubs. They come, they are better than the first year undergraduates.
Yeah. So what are the ages that you're targeting here?
The age we are targeting is high school. No, it's not high school, but 13 up.
Okay.
I think what you say,
Middle school, yeah.
middle school and high school.
Yeah.
So, and I'm going to, because there is a live interview for you, not for you. They're going to come to the auditorium for you. I have to say why you're here. If you could say a few words in English for them, why is important to educate? That would be good for me.
Sure.
More than, but then if you do that, I can send you a whole collection for you to, I know that you like to go to schools and everything. You can present the high school that you please.
Yeah.
Let me go see
Okay.
that. David, can you say a few words?
Well, I
So,
it's very impressive what you're doing
Yeah, but if you say a few words, look, we have to.
Oh, you mean at the
young
interview?
people
Sure,
To have good people.
sure.
We cannot have good universities and poor high schools.
Yeah.
Professor,
Euclides,
só peço.
Euclides is part. Euclides. It's part of the whole program of fusion.
Professor Euclides Marega, nesse momento, juntos com os prêmios Nobel, também nessa área de difusão científica,
Yeah.
We're gonna say to them, they're gonna frame it because we're gonna put in your.
explicando todo o desenvolvimento para eles e a aplicação desse trabalho de difusão feito pelo Centro de Pesquisa em Ótica e Fotônica.
Yeah. Okay. So it's absolutely necessary that we educate our young people starting at a very early age in the basics of science and technology, because our society today needs people that are educated in science and technology, whether they are working in the field of science and technology or just citizens of our society where science and technology are so important. And kids like these are really the kind of thing that can capture the imagination of children, to be able to play with the components of a kit like this can really spark their curiosity and their imagination. So I think this is absolutely wonderful.
David?
Well, I don't know whether I have anything to add. I think Bill said it very well. So no, it's really impressive what's going on here. Yeah, it's great.
Então, dessa forma, a gente continua aqui, tá? E junto com os prêmios Nobel que estão aqui, acompanhando todos os trabalhos do Centro de Pesquisa em Ótica e Fotônica da USP, aqui no IFISC. Estamos com vocês. Nos acompanhem.